One of the topics in mathematics that we're going to rediscover this semester, something that you should have taken in previous math classes, is imaginary and complex numbers. We're going to be using this because it simplifies the mathematics quite a bit. And now Giancoli doesn't use imaginary or complex numbers, so this is beyond what the book talks about, but it will make the problems that we solve a little easier in some cases. Now, remember that we have the square root of -1, and that's defined by the letter I. And for us engineers, we don't really like using, especially the electrical engineers, we don't like using the letter I because we're going to be using this to define electric currents. So we take and use the letter J, which is interesting because J is also used in electrical engineering, but I guess because it's not used as much, although we will be using J to define something else this semester, but either one of these are acceptable. You can use I or you can use J, either one. I tend to use J just out of habit because I've used it for so many years. But just let you know that when you see J, I'll be talking about square root of a -1. If J is something different, I will make sure to define that so you know that it's not the imaginary operator. So imaginary numbers are just, let's write them, are just the sum multiplier times the imaginary number. So you could have 3J, 5J, 7J, anything. But it's just the imaginary part. If we have a complex number, well, that just has a real part added to it. So it's in some form of A plus BJ, and that could be 2 plus 3J, or 6 plus 5J, or let's say 10 plus 7J. It'll have a real part connected to it. Now, the operations for complex numbers are actually fairly simple. If I want to add two complex numbers, well, it's just adding the real parts and adding the imaginary parts. And imaginary numbers are distributive, so you can distribute this J inside of the parentheses. Now, of course, subtraction is just a different form of addition, so we really don't need to do that. The other is multiplication. And use the face or FOIL method. No, I don't need to use the parenthesis there. So I'm going to have A times C. I'm going to have A times DJ. Then I'm going to have BJ plus C. And then I'm going to have BJ times DJ. Okay, so AC is pretty simple. I can add these two in the center. And this last piece here is BDJ squared. So now I got to figure out what to do with this J squared. Well, let's look at the different powers of J. Well, J to the 0, well, anything to the 0 is 1. J to the first is just J. J squared, well, if I look up here, if I take and I square J, that means I square this other side, and that just gets rid of the square root operation, and that leaves me with -1. Make sure that you understand this, because many students will say J squared is equal to 1, and it's not. Now, J to the third is going to be J times J squared, and that's just going to be, well, J squared is -1 times J minus J. J to the fourth, well, that's going to be J squared times J squared, and that's -1 times -1 is equal to 1. And J to the fifth just ends up taking you back to, well, here's 1. That's same as J to the 0. When I do J to the fifth, I'm going to have a J to the fourth times a J, so that takes me back to this point here. And that just means it cycles through. So J to the fifth is J, J to the sixth is -1, J to the seventh is minus J, J to the eighth is 1. And they just keep cycling through. So in this case, then, I can simplify this. AC plus the quantity A times D plus B times C, quantity times J, and then J squared is going to be a -1, so I'm going to have minus BD. And now I can combine this, AC minus BD plus AD plus BC, quantity times J. Now our last operation is going to be division. So we have A plus BJ over C plus DJ. And if you remember back when we were simplifying problems with square roots, the way that we got rid of the square roots in the denominator was to multiply by 1, but we did it in such a way to get rid of the square root in the bottom, and we did that by using the conjugate. Now the conjugate is just taking, if I have C plus DJ, its conjugate, which we normally write a line above it, is equal to the changing of the sign in front of the square root, or in this case, the imaginary number. It's very important. Never do it in front of the real. Always do it in front of the imaginary. So in this case, I would have C minus DJ. That's the conjugate, the complex conjugate for this. So I'm just going to multiply by 1 in the form of C minus DJ on the bottom and c minus dj on the top. This part here is just 1. And now I can multiply through. Well, we did something similar to this over here, but it's a little bit different. So I'm going to have AC minus DAJ, or ADJ. Let's put it in alphabetical order. And then I'm going to have plus BCJ. And I'm going to have minus BJ times DJ over, and on the bottom I'm going to have C squared plus, actually it should be minus, because I'm going to do the C times the minus DJ. So it's going to be minus CDJ, and then I do this one, that's going to be plus CDJ, and then I'm going to have a minus D squared J squared. Now we can simplify. And I'm just going to rearrange these just so I can keep the plus there. So it's going to be BC minus AD minus BDJ squared. And for the bottom, I'm going to have C squared. These two are going to drop out. And I'm just going to get minus D squared J squared. Now I can simplify more. I know J squared is minus 1. Minus 1 times the minus is going to give me a plus. So I'm going to have AC plus BD plus, I forgot to put my J here. Oh, it's BC minus ADJ over, and I have J squared here, which is negative 1. That's going to give me a plus there, so I'm going to have C squared plus D squared. So these are the different operations for imaginary and complex numbers. We'll be using these quite a bit this semester.